Hi everyone. We are looking at finding constant rate of change and sort of translating our knowledge of graphing to real world situations. So for this first problem, it asks us to find the constant rate of change or slope for this linear function and interpret its meaning. So first we have to look at our graph. We see our x-axis is labeled number of bags, and our y-axis is labeled number or total sales, so like the amount of money sold. You can see they're labeled differently, so that's super important. So let's first try and find our rate of change. So we look, how much is this one increasing by? Each step we're increasing by 5. Right? So we're adding 5. If we look at our y-axis, each step we're going 10, 20, 30, 40, so we're increasing by 10. So our rate of change or slope is always written the amount of change in y over the change in x. So change in y over change in x. So our change in y is our blue axis, which is $10. So we're increasing by $10 over the amount of change in our y-axis, or our x-axis, which is our number of bags. So $10 for 5 bags. We can, of course, reduce this, right, because it's just a fraction. Those are both divisible by 5. So if we divide both those numbers by 5, we're going to end up with $2 per 1 bag. So that's what our constant rate of change is. So if we think about what that means in real life, is that for every bag, we're increasing for $2. So the constant rate of change is $2 per bag. And you can see that's a rate, right? $2 per bag is our rate. So that would be the number attached to the x if we were going to put this into an equation. Okay, moving on. So what are we going to learn today? We are looking at writing functions from word problems and graphing them. So let's look at this first example. The graph shows the cost of different amounts of trail mix. Determine the equation that can be used to model this situation. So our cost y over our cost x, or our weight x. So you can see they kind of set it up already for us. So we just look at our change in x's, change in y's, and we can figure it out. So if we look at these, we're going 2, 4, 6, 8, 10, right? So we're increasing by 2 each time. If we look at these, we're going 7, 14, 21. So if we add those up, we're increasing by 7 each time. So our cost y is $7 per 2 pounds of weight. And we use LBS to do pounds. So our increase is $7 per 2 pounds. So determine this. So this is our rate of change, right? So our rate of change. So if we wanted to make this into an equation, our normal kind of equation is this: y equals mx plus b, where m is our slope and b is our y-intercept. And this is what we've been doing for the last couple days. We just haven't been writing it in this way. Basically, what we want to do now is just replace each of these numbers with what we can find from our graph. So our slope is kind of the hard part. That's the part we just calculated. So for our equation, we're going to say y equals, and then instead of m, we're going to put 7 over 2. So 7 over 2, and then we're going to put the x. Then our y-intercept is where we cross the y-axis. We cross the y-axis right here at 0. So it would be like this, plus 0 kind of. But plus 0 doesn't really mean anything, so technically we could just leave that off if we wanted and just say y equals 7 over 2x. And that is kind of how we can create an equation from this word problem and this graph here. Okay, next one. So the equation y equals 40x represents the distance y in miles an ostrich can travel in x hours. So let's label our axes first, then we can look at how to graph this. So this is in y equals mx plus b form already. We just don't have a b value, just plus 0. So it says distance y in miles. So my y-axis is going to be miles. An ostrich can travel in x hours. X-axis is going to be hours. So if we go 40x, we're not going to be able to graph that because our graph only goes up to 12. So we're just going to have to change this. So what if I just added an extra 0 to all these and make this by tens? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. And then hours, we can just leave 1, 2, 3, 4, 5. So each hour we go, for each hour we go up 40 over 1. So we're going to start here at 0, 0 because our y-intercept is just 0 here. There's no value there, so we just start at 0. We're going to go up 40 over 1, which means right here. Up 40 over 1, up 40 over 1. So our graph is going to look like this. When we graph real stuff, we don't always have to keep going in the negative direction because we can't have negative distance and negative hours. Doesn't really work. So we're only going to graph it in this positive direction. So what we just did is we took this equation and we graphed it. The only kind of new part here that we haven't done before is that we're talking about kind of a real world situation. So we're just graphing how many miles this ostrich can go in a certain number of hours. All right, next question. So I'm going to want you to pause your video here and try and work out this problem. Okay, so write it down. It's going to be y equals 45x plus 0. Label your distance and hours on your graph, and then graph that line. And it should look similar to the one we just did. So I'm going to give you a couple minutes to work on that. Ready, set, go. Okay, hopefully you had a minute to try it out on your paper. So again, x is hours. This one's miles. Our driver can go 45 miles per hour. So I'm going to do the same thing I did last time. 10, 20, 30, 40, 50, 60, 70, 80, 90, 110, 110, 120. So at 1, we're going to get 45, which is right in between 40 and 50. So I'm going to put my dot right there. 2, we're going to go up another 45, which puts me at 90. And then we can't really go any further. So I'm just going to stop there. So similar to our last one. Okay, nice job. On to this question. So the time it takes to burn amounts of information on a CD varies directly with the amount of information. So like back in the day, we used to use CDs, and you can burn CDs with songs or whatever you're putting on the CD. So imagine you're putting on some songs. If you only do a few songs, it only takes a couple of minutes. If you do a bunch of songs, it takes a bunch of minutes. So we're saying it varies directly. So if we look at our graph, I know it's very blurry here. So we have the amount of information, so how many songs we're putting on there or whatever, and time, how long it's going to take to burn the CD. So we know it varies directly, and we know it starts right here at 0 again. We want to make an equation for this line. So we always are going to kind of start in this y equals mx plus b form, where we need to figure out our m, slope, and our b, y-intercept. Y-intercept is where we cross y-axis, 0 again. So that's pretty easy. So we can kind of start plugging stuff in. So y equals, we don't know our slope yet, plus 0. If we look right here, we went up 10 over 2.5. Right, we got 2.5. Up 20 over 5. Right, we went up 40 over 10. So we can kind of write down our slopes and figure out kind of how we want to reduce it. So let's say we went up 20 over 5. We could simplify that, divide them both by 5, which would give me 4 over 1. So our slope is just 4. Remember, we don't really put the 4 over 1. So if we were going to write this as a regular old equation, we would just write y equals 4x. We wouldn't put the plus 0 or the over 1. We would leave those blank, so we just said y equals 4x. Okay, that is it for today. So now you're going to switch gears, and I want you to go finish the assignment in OneNote. You're graphing problems today using slope-intercept form. So you need to write your slope, you need to write your y-intercept, and then graph it. So you're not actually doing what we just talked about here. This will kind of lead into our lesson for next class. All right, have a great day. I missed you at school today. Bye.